Does it seem to you that rocks never change? For example, if you were to find a chunk of granite today, would you still expect it to be granite at the end of your lifetime? Well, this may be true, but this is only because our lifetimes are very short relative to the history of the Earth. If we take a step back to look at geologic time, which focuses on the changes that take place over millions of years, we find that rocks actually do change. Although we may not be able to see the changes, the physical and chemical properties of rocks are constantly changing in a natural never-ending cycle called the rock cycle. Hi, I'm Kamesh. I'm from the Kingling Hawk 4-H Club, and today I'm going to demonstrate the rock cycle and how to identify different types of rocks. So first of all, what are rocks? According to the U.S. Geologic Survey, rocks are naturally occurring coherent aggregates of one or more minerals. Rocks can be categorized into three main groups: igneous rocks, sedimentary rocks, and metamorphic rocks. The rock cycle is the long, slow journey of rocks down from Earth's surface and then back up again. The concept of the rock cycle is attributed to James Hutton, the 18th century founder of modern geology. The main idea of the rock cycle is that rocks are continually changing from one rock type to another and then back again, as the forces inside the Earth bring them up to the surface of the Earth where they are weathered, eroded, and deposited, and as the forces on the Earth sink them back down again, where they are heated, pressed, and melted. So the elements that make up rocks are neither created nor destroyed, but are constantly being recycled. The rock cycle helps us to understand that the Earth is one giant rock recycling machine. Let's begin with the igneous rock here. The igneous rock can be weathered and eroded to turn into sediment, and the sediment may turn into a sedimentary rock through sedimentation, compaction, and cementation. The sedimentary rock may be subjected to high heat and pressure, turning it into a metamorphic rock. The metamorphic rock may be heated to the point where it melts into magma, and when the magma crystallizes, a new igneous rock forms. It is important to note that, however, this process is not always linear and does not always follow the specific process. For example, an igneous rock can be buried and metamorphosed, turning into a metamorphic rock, while both sedimentary and metamorphic rocks can be uplifted and eroded to turn into a new sedimentary rock. Rocks can also remain unchanged in stable regions for long periods of time. Let's simulate this rock cycle using crayons. To do this, we will need aluminum foil, a crayon sharpener or scraper, a bowl, shredded ice, and a candle warmer or a stove. Let's pretend that this crayon is an igneous rock. I'm going to use the crayon sharpener to show the weathering and abrasion processes. We can also scrape the crayon. The sedimentary rocks are the only rocks that contain fossils and are indicators of the climate during the period in which they formed. Since this process takes a lot of time, I've already done this step and I've scraped 3 different colors of crayons. Now I'll take each different color of crayon and add it to my aluminum foil to show the deposition process. The sediment settles and enough of it collects, and the lower layer becomes compacted so tightly that it becomes lithified, which means turn into rock. So I'm going to take the aluminum foil and squeeze this mixture with my hands to show this process. There are 3 types of sedimentary rocks: chemical, clastic, and organic. The clastic and organic rocks are formed through weathering and sedimentation. The clastic rocks are formed from large pieces of rock, which are called clast. The organic rocks are formed from biological matter, such as dead plant and animal matter. The chemical rocks begin as a chemical precipitate that is dissolved in water. When all the water evaporates, the chemical compound is exposed, which is our sedimentary rock. Now, this process is complete. And when we slowly open up our aluminum foil, we can find our sedimentary rock. And we can see that our sedimentary rock is fragile and crumbles when touched, just like a real-life sedimentary rock. This is another example of our crayon sedimentary rock. Now let's take a look at some of the examples of our real-life sedimentary rocks. The halite is a great example of the chemical sedimentary rock. The conglomerate can be identified as rounded pebbles and sediment cemented together. The anthracite coal, shale, fossiliferous limestone, and sandstone are other great examples of sedimentary rocks. Now we're going to turn this sedimentary rock into a metamorphic rock. To do this, I'm going to start by placing the sedimentary rock in an aluminum foil cup. Next, I'm going to pour hot water into a bowl. The word metamorphic means to change form. The metamorphic rocks can start out as any of the three rock types. Whenever the parent rock comes in contact with heat and pressure, the metamorphic rocks form. So I've poured hot water in a bowl, and I'm going to put my sedimentary rock into this hot water. We want to make sure the water is hot enough to change the rock, but not melt it completely. There are two classes of metamorphic rocks. The foliated rocks are formed under extremely high unequal pressure. This causes the flat and elongated minerals within the rock to align perpendicularly in layers. This causes the folds within the rock. We need to make sure that we turn our specimen so that the heat is distributed evenly on all sides. The non-foliated rocks are formed under low equal pressure. The original minerals recrystallize to a larger size, and the minerals don't line up. This is because the atoms are packed together more tightly, which causes the density of the rock to increase. And the non-foliated rocks also form whenever the parent rock comes in contact with magma. So now let's take a look at our crayon metamorphic rock. And we can see that it has changed a little bit in some spaces. Now this process will take a long time to complete. So I've already done this step, and this is what our crayon metamorphic rocks will look like whenever they are changed completely. Let's take a look at some of the examples of the real-life metamorphic rocks. The foliated metamorphic rocks, schist and slate, come from the sedimentary rock shale. The non-foliated rock marble comes from the sedimentary rock limestone. The non-foliated metamorphic rock quartzite comes from the sedimentary rock sandstone. And as I mentioned before, the metamorphic rocks can start as any of the three rock types. So that is why the foliated metamorphic rock slate turns into the foliated metamorphic rock phyllite, and the igneous rock granite turns into the foliated metamorphic rock gneiss. The word igneous means fire in Latin. Of course, the igneous rocks form when the magma solidifies and cools. The reason I set two sets of aluminum foil cups on the stove is to show the two types of igneous rocks. The intrusive or plutonic rocks, which cool inside the surface of the earth, and the extrusive or volcanic rocks, which cool outside the surface of the earth. We can even see the magma boiling with bubbles. We can also stir up the mixture to speeden up the process. So now I'm going to take one of the aluminum foil cups and let it cool on its own. I'll take the other one and pour it in this aluminum foil cup with shredded ice in it and place it in our ice bath to show the quick cooling of the extrusive rocks. Let's take a closer look at the differences between intrusive and extrusive rocks. The intrusive rocks have large mineral grains and a coarse texture, and the individual crystals are interlocked with each other. This is because of the slow cooling, which can take anywhere from thousands to millions of years. The extrusive rocks have small mineral grains and a fine-grained texture due to the rapid cooling. Some even have a vesicular and holy texture. And when we remove our extrusive rock from the ice bath, we can see the vesicular and holy texture. And we have to wait for the ice to melt completely, but I have some other examples of our crayon extrusive rocks, and we can even see the vesicular and holy texture in these crayon extrusive rocks too. Our intrusive rock needs to take a little more time to cool, but I have an example of what it looks like, and we can see the large crystals in our intrusive rock. Let's take a closer look at the real-life examples of igneous rocks. Basalt, obsidian, and pumice are great examples of the extrusive rocks. We can see the fine-grained texture in the basalt and obsidian, and the vesicular and holy texture in the pumice. The diorite, syenite, granite, and gabbro are great examples of the intrusive rocks. We can see the large crystals in the granite, diorite, and syenite, and the gabbro has a coarser texture. In my demonstration today, we took a closer look about the rocks and the rock cycle, unique features of the sedimentary, metamorphic, and igneous rocks, and how we can imitate the rock cycle using crayons. Rocks always encompass a million mysteries, and a lifetime would not be enough to solve them all. Thank you very much.